So we have the diagram, and they tell us that P1 and P2 are 4 kilonewtons. And we're interested in finding the force in all the members. We have pins at A, B, C, D, and E. So since we're doing this by hand, where's the best place to start so that we can start to get numbers right away? Here at E, so at E, if we think about E, we have 2 members attached to it, so that'll be 2 unknowns. But also at E, we have that EX and that EY from the pin. So if we start at E, we start with something with 4 unknowns, but we can only get 2 equations out of it. So again, they're good equations, but if we're doing this by hand, E would not be an ideal place to start. Right, so if you look at C, we have an external force acting there, which we know is a number, and C is attached to 2 members. So if we think about what the free body diagram will look like, there'll only be 2 unknowns if we start at C. So as a starting place, C is going to start to give us some numbers right away, which by hand is an easier way to go about this. So I would recommend starting at C for this one. Right, so we have our pin at C. We have the external force of 4 kilonewtons acting on it. And we know that direction. So what other forces are acting at C? Right, so we're going to, again, always assume tension for these. So the tension in member CB, so it acts along the length of CB. So I'm going to call that FBC. And that's going to be a 30-degree angle from the horizontal, because BC is 30 degrees from the horizontal as well. And then the other force acting on the pin at C? FCD. Right, FCD, and that's in the negative x direction. So now we actually have the free body diagram. Again, as we initially thought, there's only 2 unknowns with it. We'll be able to get 2 equations, so we should be able to solve for both of these unknowns right away. So from free body diagram C, we can sum forces. I'll actually start in this one in the y direction, just because I'll be able to get numbers even sooner that way. Because in the y, we look at the picture, CD is only in the x direction, so it's not going to be in this equation. So starting in the y direction, I'll have negative 4 kilonewtons plus FBC sine 30. So starting with equation 1 in the y direction, the only unknown there was BC, FBC. So we can get that the force in BC is going to be positive 8 kilonewtons, meaning, because our assumption is tension is positive, that BC is in 8 kilonewtons of tension. We still have sum of forces in the x direction in picture C. So in the x, we have negative FCD minus FBC cosine 30. So from equation 2, we can now plug in the value we know for FBC is 8. So now looking at equation 2, the only remaining unknown is FCD. So we can solve this directly for FCD now. So FCD, we get a negative 6.92. Kilonewtons, and that's in compression. So mathematically, this negative sign is going to be important. We have to keep track of that. And then for our interpretation of the results, again, the negative sign tells us it's compression. So the negative sign is going to be serving 2 purposes in these problems. All right, questions so far? C is a particle. We've gotten the 2 equations we can get out of it. All the forces are concurrent. So again, the moment isn't going to tell us anything. So we've used up this picture. We have 2 of our 6 unknowns, the members that we're looking for. So now we need another picture to get more equations. So now logically, what's the next place we can go? Yeah. Well, E is still going to have 4 unknowns because all we know CD and we know BC, but we don't know anything more about the things attached to E. Right, so if you look at D, though, it's attached to P1, which we know, DE, which we don't know, BD we don't know, but at this point, we do know CD. So now if we look at the pin at D, it's only attached to 2 things we don't know. So in this order, going to D makes the most sense if we're doing this by hand, because now we'll get 2 equations, potentially, and we can solve for now these 2 new unknowns. So D makes the most sense. So D, we have that external force P1, so another 4 kilonewtons down. It's attached to CD. Again, we're still assuming tension, so FCD is going to be pulling on this and pointing to the right. When we're drawing our free body diagram for the internal forces, for external forces or supports, it's different, but the internal forces, we ignore. If we know it as a number, we don't include that information until we get to solving the equations, really. So in this picture, even though we know it's in compression, to be consistent, I'm still drawing it in tension because in picture C, I also drew it in tension. So always assuming tension for these internal forces. So CD to the right. To the left, I have force DE. And assuming tension, then up, I have force BD. Questions about free body diagram D. So it is attached to 3 members. I'm still assuming tension, and that external force, I know the direction is down. So based on the picture alone at D, I'll write the sum of forces in X is going to be negative FDE plus FCD. So still, I'm not putting in numerical values for the internal forces yet. So that is the sum of forces in the X direction. Now, I know FCD is negative 6.92, so now I can substitute that in. So it's negative DE plus negative 6.92 is the final equation for 3. Now looking at 3, the only thing that's left that I don't know is DE. So DE, I also get negative 6.92 kilonewtons. So DE is also in compression. So a third unknown I found. I still have one more equation from picture D I can use. So sum of forces in the Y will give me negative 4 plus FBD. The only unknown in equation 4 is FBD, so I can solve it right away. So FBD is positive 4 kilonewtons, and FBD will be in tension. Yeah.
For equation 3, since it's a minus and another minus, we're going to do a positive?
No, because I moved DE to the other side, and FDE is negative 6.92. Yep. So you have to be careful with the signs on these because you can get multiple negative signs, so that's why I recommend you don't put the actual number in until the end. Because if we knew DE, say, was a negative, if we already knew DE was negative 6.92, when we plug that in, then we get a negative times negative 6.92 plus FCD. So it's a little bit easier to keep track of it this way, substituting it at the last minute. Question about the first 4 equations and the first 2 free body diagrams. All right, so D is done. We've used it up entirely. We still have 2 more unknowns left. So looking at the picture, what's the next point that makes the most sense? Right, so now B makes the most sense to go to next. It is attached to 4 members, but by now we know BC, we know BD, so there's only going to be 2 things left that we don't know at B. And also it's good because it's attached to the 2 members that we still don't know, AB and BE. So we wouldn't want to choose A at this point because it's attached to 3 things we don't know, AX, AY, AB. We wouldn't want to choose point E still because it's attached to 3 things we don't know, EX, EY, and BE. So B makes the most sense. I'll draw it up here so you can see it. as our what will be our last free body diagram. So no external forces are acting at B, just the forces in those four members. So we have BD down. We have AB up and to the left at 30 degrees. We have FBE down and to the left, also 30 degrees from the negative x-axis. And FBC, 30 degrees down from the positive x-axis. So sum of forces x or y, neither is going to be better than each other to start, so I'll just write the equation in the x direction for picture B. So I'll have a negative FAB cosine 30 minus FBE cosine 30 plus FBC cosine 30. First thing I could do, since they all have a cosine 30, I can get rid of that right away. So there's three things I don't know at the moment, but previously I found what FBC was, here it is, was positive 8. So I can now substitute that in down here. So I can rewrite this a little bit cleaner. So the cosines I canceled out. So equation 5, in a nicer manner, negative FAB minus FBE plus 8. So I've used up equations 1 through 4. Equation 5 has two unknowns in it, so I can't do anything numerically with it yet. So I can still write my last equation here, equation 6, sum of forces in the y direction at B. So in picture B, I'll have the negative FBD minus FBE sine 30 minus FBC sine 30 plus FAB sine 30. Here I can't cancel the signs out because FBD does not have it, but I can substitute in, again, what I already know. FBD I know was positive 4, so this becomes positive 4. And BC, again, is 8, so I can substitute that in here. So now equation 6, I still have FBE and FAB. In equation 5, I also have FBE and FAB. So both appear in both equations. So I'm down to two equations, two unknowns. So that's the only really simultaneous equation I need to solve. So solving 5 and 6 simultaneously, either through substitution or elimination, I can get my two remaining unknowns, FAB and FBE. So from those two equations, FAB is a positive 12 kilonewtons in tension, and BE turns out to be a negative 4 kilonewtons, so it's in compression.